Alright, so this is the first video in our unit on solids, and we're going to be looking at particular types of solids. Just about any three-dimensional figure that you can imagine is an example of a solid, but we're going to be looking at particular types of solids, and in this section we're going to be looking at the type of solids that are called prisms. Now, a prism is a particular type of polyhedron. A polyhedron is just a solid that has polygons for sides, and a prism is a polyhedron that has two identical bases, and the bases are parallel to each other. So you can see here are some examples of prisms. Now, prisms are named by their bases, and you can see the bases on each one of these prisms are the part of the prism that's kind of shaded in orange. So here we have a rectangular prism. It has rectangles for bases. Triangular prism has triangles for bases. Pentagonal prism has pentagons for bases. And a hexagonal prism has hexagons for bases. Now, the first thing we're going to do with our prisms is we're going to calculate their base area. Now, the base area of a prism is just the area of the two bases of a prism. So let's look at a few examples. Example number one, we're going to start out by calculating the base area of our rectangular prism. And the first thing I want to note is that the base, that is the shape of the base of a rectangular prism, is a rectangle. So if I were to draw out just the base of this rectangular prism, it'd be one of these shaded pieces here, and I can see that the length of this base is 8 meters, and its height here is 4 meters. So I can now calculate the area of the base of this rectangle. It's just 8 times 4, which is 32, and this is in meters, so I've got 32 square meters. But now I notice that the base area is the area of the bases of a prism. So I need both bases of my rectangular prism. Well, since I have two identical rectangles for both my bases, that just means the base area of my rectangular prism is going to be 32 times 2, since I have two bases, which is 64 square meters. And there's my base area of my rectangular prism. Now let's calculate the base area of a regular triangular prism, which is shown right here. So again, the first thing I want to note is that the shape of my base for a regular triangular prism is a triangle. Not only is it a triangle, but it's a special type of triangle. Since it's a regular triangle, that means it's equilateral and equiangular. Well, an equilateral triangle has all three of its angles equal to 60 degrees, which means that not only do I know what the length of my triangle is, it's 10 meters, but I can also calculate the height of my triangle, which I'm going to need in order to calculate the area of my triangle. I know the area of a triangle is 1/2 base times height. Well, I know the base of my triangle because that's given to me in this picture. So I've got 1/2, base is 10. I need to know the height of my triangle, which is this dotted line right here. Well, since the height of an equilateral triangle divides the base into two congruent sections, then I know that each of these pieces here must be 5 meters. So if this section here is 5 meters, and if this angle here is 60 degrees, and remember also the altitude of my equilateral triangle, the altitude bisects that angle, I have a 30, 60, 90 triangle, and I can calculate this height here. I remember the ratio of the sides of a 30, 60, 90 triangle is 1 to 2 to radical 3. Since this distance here is 5, I know that my height must be equal to 5 radical 3. So I plug that in here. My height is 5 radical 3. And I do 1/2 times 10. Let's see, 1/2 times 10 is 5. So that gives me 5 times 5 radical 3, which is 25 radical 3. Except, oops, I shouldn't have drawn my box around it. in order to calculate the base area of my prism, I need the area of both of my bases. So I have two triangular bases, which means I need to multiply this times 2, and that gives me 50 radical 3, and let's see, my units again are meters, so that's going to be 50 radical 3 square meters. All right, now let's take a look at how we calculate the base area for a regular hexagonal prism. So again, the first thing I want to note is, what's the shape of my prism? Well, the shape of the base of my prism. So in this case, my base is a hexagon, which means I need to know how to calculate the area of a hexagon. Well, I know how to calculate that. The area of a hexagon is 1/2 times the perimeter times the apothem. Well, again, let me kind of break out my hexagon shape over here, and let's see, according to my diagram, each one of the sides of my hexagon, remember it's a regular hexagon, so each one of the sides is 4 feet. All right, so I know the length of each one of the sides. One side is 4 feet. I've got 6 sides, so 6 times 4 is 24. So right away I know what my perimeter is. Now I just have to calculate the apothem. Remember, the apothem is the perpendicular distance from the center of the hexagon to one of its sides. So I need this distance right here. That's my apothem. Well, I also remember that I can calculate this central angle of my hexagon by taking the total amount of all of the central angles, which is 360 degrees, and divide that by each one of these angles here. Well, since it's a hexagon, I have 6 of them, so 360 divided by 6, that gives me my central angle. 360 divided by 6 is 60 degrees, and so right away I have another 30, 60, 90 triangle. Oops. This is my 30-degree angle, and this is my 60-degree angle. So now I can calculate the length of this side, my apothem. I know that the length of each one of the sides of my hexagon is 4 feet, and the apothem divides this into 2 congruent segments. So this is 2 feet here, and this is 2 feet here. And I have a 30, 60, 90 triangle, so I know the ratio of the sides is 1 to 2 to radical 3, so that's 1 to 2 to radical 3. My apothem then must be 2 radical 3. Now I have a value for my apothem. I can plug that in here. My apothem is 2 radical 3. Now I can calculate the area of my hexagon. 1/2 times 24 is 12. 12 times 2 radical 3. So 12 times 2, so that's 24 radical 3. And now again, I'm not finished because I want the base area of my prism, and the base area is the area of both of my hexagons. Well, they're both identical hexagons, so I just need 2 times 24 radical 3, and that gives me 48 radical 3. And let me see, my units this time are in feet, and this is area, so this is 48 radical 3 square feet. And that's the base area for my hexagonal, my regular hexagonal prism. All right, now we're going to calculate the lateral area of our prisms. And in order to calculate the lateral area, we have to note something called the lateral faces. The lateral faces are just the sides of a prism. So anything that's not a base, that's considered a side of the prism. And the lateral area is just the area of the sides of a prism. So it turns out that for example number 2, this is the same rectangular prism that we looked at in example number 1. Each one of the sides, and I've got 4 sides in my rectangular prism, this side on the front, these 2 on the sides, and then the one that's kind of on the back side of the prism. And each one of those, I note, has the shape of a rectangle. So let's see, let's do the front side first. That would be this rectangle with this base and this height. So let's see, the area of the, let's say the area of the front is, let's see, my base is, that's 8 meters. 8 meters times, let's see, the height is the same as the height over here, which is 5 meters. So that gives me 8 times 5 is 40 square meters. Now I can also calculate the area of the back side of my rectangular prism, and it's going to be exactly the same as the area of the front. 8 times 5, 40 square meters. Now let's see, I want to calculate the area of these 2 side pieces, and that's going to be, let's call this area side. See, that's going to be 4 times 5, which is 20 square meters. And the area of the other side is exactly the same, so that's also going to be 4 times 5, which is 20 square meters. And since the lateral area is the area of all the sides of the prism, I just need to add those up. So 40 and 40 is 80, 100, 120 square meters, and that's the lateral area of my rectangular prism. If I want to calculate the lateral area of my triangular prism, well, let's see. I've got the height of my prism is 50 meters, that's this distance here, and the sides of my prism, I have 3 sides. I have these 2 here, and then I've got the side that's on the back. And let's see, the length of one side of my triangular base is 10 meters. Since it's a regular triangular prism, that means the length of every single one of these sides is 10 meters, so this distance is 10 meters as well. So I just have 3 identical rectangles as the sides, the lateral faces of my regular triangular prism. So let's see, the area in this case, again, it's a rectangle. It's going to be 10 meters times 50 meters, which is 500 meters. I've got 3 of them. 10 times 50, 10 times 50. And I add those 3 together, that gives me 1,500 square meters. And that's the lateral area of my regular triangular prism. Now to calculate the lateral area for my hexagonal prism, again I'm going to do the same thing. I note that each one of the sides, that is each one of the lateral faces of my hexagonal prism, is again a rectangle, so I just need to calculate the area of one of those rectangles. My height is 12, and since it's a regular hexagon, the shape of my base is a regular hexagon, that means every one of these sides is 4 feet. So the height here is 12, the distance there is 4, so the area of my rectangle, that is one of my rectangular sides, is 12 times 4, which is 48. So that's the area of one of my rectangular sides of my hexagonal prism. Well, since I have 1, 2, 3, 4, 5, 6 of those sides, I need to multiply this times 6, and that gives me 288. Let's see, my units here are feet, so that gives me 288 square feet for the lateral area for my regular hexagonal prism. Now, total area is just the sum of the areas of all of the bases and all of the sides of a prism. And we kind of shorten it to look like this. Total area equals base area plus lateral area. And there are examples, I believe it's example number 3 in your notes, asks you to calculate the total area for each one of those 3 examples. And I'm going to leave that to you, but the total area is just the base area, which you've already calculated, and the lateral area. So add those values together, and that will give you your total area. Now let's take a look at how we calculate the volume of our prisms. First, we note that the altitude, or the height, of a prism is the perpendicular distance between the 2 bases. And the volume of a right prism is the area of one base times its height. And we abbreviate that like this, capital B times height. Notice that I tossed in this extra word here, a right prism. All of the prisms that we're going to be studying in this unit are right prisms, and that just means that the angle formed between one of the bases and one of the sides, it's always a right angle. There are other types of prisms, but we're not going to look at those other types. We're just going to look at right prisms. So the volume of a right prism is the area of one of the bases times the height of the prism. Well, we've already calculated the area of one of the bases for each of our 3 example figures. So all I need to do is use that area that I've already calculated, find the height of my prism, and I can calculate the volume. So let me look back in my notes here. The base area, let's see, the area of one of my bases for my rectangular prism, that is 32. Notice I'm only using the area of one of my bases, not both of them. So the area of one of my bases is 32. The height of my rectangular prism is 5. So 32 times 5, which is 160. Now this is volume, so this is going to be in units of meters cubed. All right, let's see. I want to do the same thing here for my regular triangular prism. Let me look back and see what is the area of one of my bases, which I calculated before. That's 25 radical 3. The height of my prism here is 50. And so I need 25 radical 3 times 50, which gives me 1,250 times square root of 3. And again, this is in meters cubed. Finally, again, I'm going to use this same formula for the volume of my regular hexagonal prism. So the volume is just area of one base times the height. Let's see, one base, look back in here at example 1, the area of one base for my hexagonal pyramid, my hexagonal prism, is 24 radical 3. The height of my hexagonal prism is 12. So I need 24 radical 3 times 12, and that gives me 288 radical 3, and my units here are feet, so that's going to be cubic feet. So 288 radical 3 cubic feet is my volume. Now, you have one more example in your notes, example number 5. In example number 5, I ask you to find the base area, lateral area, total area, and volume for a regular triangular prism. And I'm going to leave that one for you to do, and we'll take a look at that in class tomorrow.